Welcome to another edition of Math for No Reason. In this edition, we will be proving this identity which states that cos of 5x is cos to the power 5x minus 10 cos cube x sin square x plus 5 cos x into sin to the power 4x. How do you prove this? One idea could be that we can use the formula for cos a plus b multiple times and prove this, which is a correct approach and would lead to this result. An alternate would be to use a very famous result from complex numbers, which is known as the Moivre's theorem. So let's use Moivre's theorem to prove this result. Now, what is Moivre's theorem? Moivre's theorem tells us that cos x plus I sin x whole to the power n is cos of nx plus I sin nx, where n is a natural number. Now, from the Euler's identity, we know that e to the power ix is equal to the cos x plus I sin x. Therefore, the left hand side is equal to e to the power ix whole to the power n, which is e to the power inx. And when we expand e to the power inx, we get cos nx plus I sin nx. So, using the Euler identity, the proof is very straightforward. Now, suppose n is 5 and let us use the binomial theorem. So, we have cos x plus I sin x whole to the power 5, and by binomial theorem this becomes cos to the power 5x plus 5 cos x to the power 4 into I sin x plus 5c2, which is 10 into cos cube x into I square sin square x plus 10 cos square x into I cube sin cube x plus 5 cos x I to the power 4 sin x to the power 4 plus I to the power 5 sin x to the power 5. And by Moivre's theorem, we know that this is equal to cos 5x plus I sin, and we will use this fact. Now we equate the real parts. So we identify the real terms. So this term is real, it's underlined here. This term is real, and this term is also real. So cos 5x, which is the real term in this equation, becomes equal to cos x to the power 5 plus 10 cos cube x into I square sin square x. So I square is minus 1. So we get minus 10 cos cube x into sin square x. And since I to the power 4 is 1, we get 5 cos x into sin x to the power 4. So which proves the result. As a bonus, we also get the result for sin pi x by equating the imaginary terms here, and all these terms that I am circling now are imaginary terms. So we get sin 5x is equal to 5 cos x to the power 4 into sin x. I cube is minus I. So therefore this becomes minus 10 cos square x into sin cube x, and I to the power 5 is plus I. So therefore we get plus sin x to the power 5. So we get both these results using the Moivre's theorem. It's a good point to stop. Thank you.